Let's briefly talk about the bipolar transistor and NPN transistors small signal model. So you have the transistor, collector, base, and emitter. Emitter is the arrow. Arrow is looking outside. That means this is an NPN transistor. So you have the R pi. This is like the resistor that's between base and emitter. And then you have an ideal current source that's controlled with the V pi or VBE. I'll make this V pi so it's the same. So this current source is controlled by this voltage, your base emitter voltage, or V pi, and you have an output resistance. So what is this R pi, GM, and RO? Here, right under this post-it note. So R pi is beta over GM, GM is IC over VT, and RO is VA over IC. So let's calculate some typical values for these. Here are the typical values. So let's say beta is 80, the collector current is 1 milliamp, VT, that's your thermal voltage thing, that's 25 millivolt, and VA, that's the early voltage, that's 5 volts. So using these equations and these, RO, VA over IC, they'll give you 5 kilo ohm. The GM is going to give you 0.04, is either amp over volt or 1 over ohm. I want to write also 1 over GM here because that's the resistor value, 1 over ohm, 1 over GM, ohm, and that's going to give me 25 ohms. And if I write R pi from these equations, it's going to give me 2 kilo ohms. So I want you to pay attention here is that 1 over GM is much smaller than RO, and 1 over GM is also much smaller than R pi. This is something we're going to use it.